Now that we know a little bit more about surface tension and cohesion, we can start our carnation activity. For this activity, you need a flower. You should all have one at your desk. A colored water glass, and a sharp knife. Now, we're going to use a sharp knife rather than scissors because scissors tend to crush the stem of the flower, and this could hurt a flower trying to absorb some water. Now, please make sure that I'm the only one that handles the sharp knives. I do not want anyone to cut themselves. This could be a safety issue. Also, each student should have a sheet. Okay? This is for observation purposes. We are going to have an at the beginning box and after so much time has passed box. Okay? We are going to make observations over a period of time. So what we are going to do first is take our pencils, and you have an option. You can draw or you can write. If you are going to draw your flower, please do so as best as possible, as accurate as possible. Make sure you draw it true to form. We want to know exactly what the flower looks like at the beginning of our activity. If you are deciding to write rather than draw, please use very descriptive words so that you can accurately account as to how the flower looks at the beginning. Okay? Once you've done that, go ahead and set this aside. To start the activity, we're going to take the flower and cut the end at a 45-degree angle. And throw away any excess that you have. Go ahead and place the flower within the colored water. And that is it as far as the activity part of this goes. Now the rest of it, the hard work part, comes when we have to observe. Okay? We are going to be looking at the flower, at the bloom at the top, and see if there's any differences. Because remember, we predicted that the colored water would be absorbed within the flower, and eventually we would see it at the top. Okay? Now, I think a minute has passed. Go ahead and look at your flowers. Do you see any changes up at the top? If you do, please document it on the right-hand side of your observation sheet. If you are drawing, once again, try to draw it accurately so that you can tell whether or not there have been changes in the flower. And if you were writing, same thing as before, go ahead and write very descriptive words so we can tell the differences. And I don't know about you, but I don't see any changes. Now, we have a flower up here that was cut about 10 minutes ago. And if you see this one up here, there are no changes in it. So, no changes after a minute, no changes after 10 minutes. Now, if we were to continue this over a long period of time, I would have you observe it after an hour, after 5 hours, after 24 hours. But we all know that we're not in class that long. Okay? So, what we are going to do, though, is we're going to look at one that I have placed in a cup that has been in there for about 2 days. Okay? Here it is. It was placed within this green food coloring about 2 days ago, 48 hours ago, and as you can see, the edges of the petal are very green, as well as the base of the petal. So, what can we tell now? Were our predictions correct? Did the flower use capillary action to draw up the water and disperse it within the stem, the leaves, and the petals? I think we can say that it did. Okay? Much like other plants, this carnation has a green stem. Okay? We've also seen trees and bushes that have a wooden stem. This is called a trunk. Okay? They use the fibers, the special tubes that are within, and you should have seen that when we cut the stem off, the special tubes. to draw in the water through capillary action and then disperse it throughout the flower. Pretty cool idea, isn't it? How that flower can draw up that water that easily. Now, just to make this activity a little bit more interesting, I want to ask you guys a question. Are carnations the only plant that we can do this with? What do you think? Can this activity be planned with any flower for that matter? Do all plants use capillary action? Could we see it in a daisy? I think this is something that we want to try next, is try it in a daisy. See if a daisy will absorb the water the same way as a carnation. Something else that I want to try with you guys is, let's make this a little bit more challenging. We'll use carnation, but instead of just cutting the bottom off of the carnation, let's go ahead and split the carnation stem in half and place half of the stem in a red glass and put the other half in a blue glass. What do you predict will happen? Well, let's find out. I did this one yesterday, and I placed half of the stem in red and half the stem in blue. Up top, we see that half the petals are reddish tinted, and the other half have a bluish tint around the edge. Pretty cool. And finally, I want to ask you one more question. If we were able to see the absorption in one flower, what if I had a stem of a flower that had multiple blooms on it? Such as this. This carnation has multiple blooms that are open. It has a couple getting ready to open, but it also has these ones that are opened already. If I were to place this in a colored glass, or colored water glass, would the blooms each absorb the water and turn color? What do you think? Or would one just absorb it and the rest of them not? Or what if I decided to split the stem once again and place it in two glasses? Would one bloom turn out to be one color and another one turn out to be a different color? Or would each of them have the two colors in each bloom? I think this will be a fun activity for us to try in a little bit. But I do want us to get our KWL charts out again. And let's fill out what we learned. I think we learned quite a bit about flowers and how they absorb water. Once you've done that, go ahead and pass those sheets forward, and I will collect them. This is what I will be assessing you on, how accurately you can tell me what we've learned. And that is the end of my teaching video assignment.